So this is my video looking at the time value of money for my class, Corporate Finance, Finance 571 at the University of Phoenix. We may hear some noise in the background or music. That's because I live in a sober sorority, so you're getting the authentic college feel here. So our first question that we're going to look at is if you want to have $500,000 in 20 years and you get a 15% interest rate, how much would you need to invest now? Anytime we're talking about what we need to invest now, we're probably looking at the present value. So the formula for present value, the equation is C1 over 1 plus R, and this is our time. So C1 is the amount that we're saving for, R is our interest rate, and time, of course, is going to be the 20 years. So we just carry down our present value formula and we pop in our numbers for our circumstances. So here the amount that we're saving for we know is $500,000. We know that it's 1 plus R, 1 plus the rate. Our rate is 15%, so we make that into a decimal, 0.15, and our time is 20. So we do what's in the parentheses first, and so our present value is $500,000 over 1.15 with a time period of 20 years. So here we just simply divide these numbers out. We just write it out like this. I personally use a calculator, and I like to use Excel for a calculator, and you just enter that directly into Excel. It looks just like that. The $500,000 times the 1.15 over 20 years. And so you can see clearly that your answer is you would need to invest $30,550.14 if you wanted to have $500,000 in 20 years at a 15% interest rate. That's fairly straightforward. We're going to do another problem, and we're going to be looking at future value. So the question here is, if you have $200,000 to invest over 5 years and you get a 5% interest rate, how much would you have? And so our formula for future value is CO times parenthesis 1 plus R, and that's our time period. So our CO is our initial investment, our R is our interest rate, and our T is our time. We plug in our own values. So we know that our initial investment is $200,000. We times that by 1 plus our interest rate. We change this to a decimal, so 5% becomes 0.05, and our time period, which is going to be 5 years. And so, of course, we do our parentheses first. So this is going to be 1 to the 5th power, and we carry this down, $200,000. So it looks like that. And then we can go ahead and we can figure this out by simply putting it into Excel. And so I just like to use Excel as my calculator, and you just pick a cell and you go equals. Don't forget your parentheses. Whoops. Looks like I didn't get the equal sign in there. Don't forget your parentheses. And it is 1.05. Don't forget your parentheses. And then that little guy right there, and 5. So it's going to equal $1.276. And you can always double check and see if you did that right by simply looking up here. So that's exactly what that says. So we can put we can feel confident, times 1.276. We just carry our 200,000 right down here, and that's our future value. And so then all we do is we just divide that out. Just come down here and you go, whoops, once again, equals 200,000 times 1.276. 1.276 equals, and you can always double check, like I said, by looking right here. You got your 200,000 times 1.276. And that's exactly what we had here, 1.276. So we know that we would have $255,200. So $255,200. This is what you would have if you invested your $200,000 for 5 years at a 5% interest rate. So we have another problem that we're going to look at, and it is if we're shopping interest rates to get to a financial goal. So this came from Rodick D, 2015, How to Calculate the Unknown Interest Rate for Present Value, and it was retrieved from www.pocketsense.com, Calculate Unknown Interest Rate, Present Value, 24086 HTM. And so our question is, you're shopping interest rates to get to a financial goal. So let's say you have $100,000 and you want it to be $300,000 in 10 years. What interest rate would you have? So here we're going to use a variation of the present value formula, and that's going to solve for R, or the rate of interest. And it looks like this. R equals future value divided by present value. Looks like that. So we plug in the information that we have into this particular formula. And so we're going to go R equals our future value. That's what we want to have. We're going to divide that by our present value. That's what we have. And our year, we know, is 10 minus 1. And so the next thing that we want to do is we want to look at doing what's in our parentheses. And so I just like to keep carrying it down. So I just go R, and then we look at these. And we say, okay, that's going to be our 3. Keep that in a parentheses. This is going to be our 0.1 minus 1. And so then we figure these out. And you can do it in Excel. That's probably going to be simply by going equals. Yes, I do that every single time. So that's definitely something that I do. So you're just going to go 3, and you're going to go like that, and don't forget your parentheses, 0.1. So it's going to look like that. And if you hit enter, you're going to see that that's 1.16. And so you're just going to go 1.16. Actually, sorry, 1.116 minus 1. But you're going to want to bring your decimal point back over. So we have 1.116 minus 1, obviously, so we know that that's 0.116. It's pretty easy to figure. And then you're going to want to bring your decimal point back over 2 spots. So what you're actually going to come out with is 11.6%. And so what that is if you had $100,000 to invest now and you wanted it to be $300,000 in 10 years, you would need to have an 11.6% interest rate. And so that's the formula, and it just very simply solves on down. So we've been asked another question, and it's related to annuities. And annuities are very common according to the authors of the text. We see them in retirement pensions, and we see them in mortgages. Now, the formula is different from the first 3 we've discussed, but the formula is pretty straightforward. So the question that we're being asked here is that a company buys an annuity that pays $50,000 a year for 10 years. And it's at an 11% discount rate. What is the annuity's value on the date that you purchase it? So again, we're talking about on the purchase date or now. What's it going to be right now? So we're looking at a present value again. And this is what the formula actually looks like here is C. And this one's got some brackets in it. You're going to go over R. And you're going to go minus 1 over R. 1 plus R. Sure that's clear. And this is going to be time. And that is going to be in a bracket. So that's what the actual formula looks like. And so we do the same thing with this formula, and we just start to plug our answers in. So our C, this is our 50,000, and then we'll just keep our brackets here. R1 over R, our rate. It hasn't changed, looks just like that. And it minus, and then R1 over, again, our rate. And then we just go 1 plus, again, our rate. It's pretty straightforward. As you can see, it's not really too tricky. You just have to plug your numbers in. Our time, just like it's been, this is going to be our time, and that's 10. It just looks just like that. And so it's important to keep everything orderly so that you can follow your work down. And so you just kind of start where you are and start working out your parentheses. And so working out your parentheses, it would go like this. You would go your 50,000, 1 over 0.11 minus, this is going to be your 1, and 11. So here's your first parenthesis here that you're going to want to work out. You're going to want to do that 1 plus 0.11. So it's going to be just like that. 10. Just like that. And then the next thing that you're going to want to go ahead and do is you're going to want to bring it down, and you're going to want to figure your 1 over 0.11. So you can just simply throw that into a calculator, just like this, which is going to be 1 divided by 0.11. So you can see that's 9.09. So you can go ahead and put that there. 9.09 minus your 1 over 0.11, 1.11. And then you just bring it on down again. You're still going to have your 909. And here we're going to work on what we see here. And so what that is going to be a 1. And so it's just going to be your 0.11 times, this would be a times, your 1.11 to your time periods. So you can throw that into the calculator. And it would look like this. It's just going to be your 0.11 times your parentheses of 1.11, your parentheses, and then your time period is going to be 10. So as you can see, it's 0.312. So that's what you're going to put here is 0.312. And your parentheses. So now it's starting to look a little simpler. So now we start to see that we've got R5. And we've got our 9.090 minus, and so we simply do that, your 1 divided by your 0.312. So throw it into a calculator, and it is 1 divided by 0.312. Move that out of the way so you can see a little bit better. And we get 3.205 minus 3.205 in your brackets. And so from there, we can fairly easily throw that into the calculator. So in our simple subtraction here, we just subtract 3.205 from 9.090. So just on your calculator, or you can do it by hand, it's fairly simple. We just go 9.090 minus 3.205. Probably want to go back up here and throw in our equals so that it actually gives us back a number, hopefully. 5.885. So 5.885 is what is actually called your annuity factor. And so with your annuity factor, you're able to simply multiply. So you're able to take $50,000 and just multiply it by that. This is going to give us what our annuity is worth right now. So just throw that into a calculator, or you can multiply it. It's fairly simple to multiply it out by hand as well. I think that most people today probably use Excel or some type of calculator. I don't see many people that in the office, I don't see many people that do it by hand. And so that is going to be your answer. $294,250. That's what your annuity. $294,250. That's what your annuity is worth now, if it pays out $50,000 over 10 years at an 11% discount rate. So that's how we figure that out, and I've shown you how that gets figured out all the way down. So now we're going to talk about a little different kind of a problem. Let me go up and just erase our calculations here. Now we're going to talk about a little bit different kind of a problem. So as you can see in this video, we're talking about our net present value, and that's used to help investors decide if a project is going to be beneficial. It uses all cash flows, including the discounted cash flows. And we're looking for values greater than 0. It's a widely accepted method because it accounts for the time value of money and specifically uses cash flows instead of earnings, according to the authors of our text. We're also going to look at the payback method, which calculates how long it takes to break even on an investment. And it's fairly easy to comprehend, although it does ignore the time value of money, according to the authors of the text. We're also going to look at IRR, the internal rate of return, and it's used on projects that involve an internal interest rate, not the prevailing ones. The point is to find an IRR greater than the discount rate. But the downfall to this method is that it doesn't tell the difference between investing and borrowing, and there could be more than one IRR. But it is another method that's fairly easy to understand, and therefore it's fairly easy to communicate, according to authors of the text. So just to see how some of that plays out, we're going to do here, we're going to look at some net present values, and we're going to exclusively use Excel. We're not going to do anything on paper. We're going to use Excel to figure this one out, and the payback method I have on another sheet. So this is to look at two different projects. So let's say we have project A, and let's say in project A we invest $10,000. So we invest $10,000 in project A. Let's say that it's expected to pay $5,000 in the first year, $5,000 in the second year, and $5,000 in the third year. So it would look like that. and there's nothing, as you can see, that's really set up. There's no specific formula. We have just set it up with our years, 1, 2, 3, our cash flow amounts right in here. And then our interest or required return on these projects. So our interest rate for this particular project is 10% on all of these. So we're just going to pop in a 0.10. So that's our required return. So we go down here and we do our NPV. So the correct way to do the NPV is to just simply go equals NPV. And so then what it wants to look at is it wants to look at your initial investment, that, and you're going to put a little comma because that's your initial investment. And then you're going to want to have your cash flow times. So it's going to be this. Whoops. So let's see if we can get that to, see if we can get this to act right here. You can just also enter it in C2, and you're just going to do it through your cash flow period, which is going to be E, or it's actually C3 through E3. So you just enter that in there. So much easier to do it in Excel than to do it by hand. And then here it's just going to be a plus, and it's going to be your initial investment. And that's going to be your B3. Actually, I think since I have B3 in here twice, that's signaling me that something is wrong. And I think that at this initial B3 right here, your NPV is actually your interest, your return rate. So this should actually have been what's in this first cell right here. So let's go ahead and correct that. Let's go ahead and make that a B5. And if this is your, there we go. See, now you got it nice broken out and you can see what it's saying. So this is your rate right there. And then these are your values, your cash flows. And then what you're doing is you, of course, are adding your initial investment. So let's see what it comes out as. And there you go. Your net present value of that is going to be $2,434.26. Let's look at another project. Hopefully we'll get these entered in and it won't be quite so confusing as that one was. So let's say you invest $55,000 into this project, and let's say in the first year you're expected to get back $20,000. In the second year, expected to get back $20,000. In the third year, you're expected to get back $20,000. And so your rate of return, of course, we said that it's going to be the 0.10. It's going to be 10% for all of these. And so again, we go down here, and what we want to do is we want to go NPV, net present value. And then the first one we want to do is get our rate in there, a comma. And then we want to get our values. And it looks just like that. And then we want to get our comma. And then we want to get plus. And we want to get our initial investment. And let's take a look at this here and make sure that I see that we got C. Let's make sure that these are right. This should be C. So just looking at it to make sure that we have the right thing. It's definitely the C12 as our cash flows through E12. We can see that up here. plus our initial investment. So it looks as if this one we're not going to go with, because we're definitely not going to get our money back. So which one of these two would I go with? I would definitely go with Project A, because Project A has definitely a more significant net present value.